A local store owner believes that the soda cans he buys from a local distributor are defective. The company claims that only 2% of their cans are defective. From the 10,000 cans in the last shipment, the owner takes a random sample of 800 and finds that 24 cans are defective. Is there evidence too many cans are defective? The first condition we need to check is the randomness condition. As the problem states, these cans are randomly selected. So with this in mind, we know that we pass the condition because the problem says we pass it. Next, we need to check the 10% condition. The 10% condition states that we need to sample less than 10% of the total population. The population here was 10,000, and 10% of that would be 1,000. Thus, our sample of 800 is less than 10% of the population. Finally, we need to pass the success-failure condition. Since we're doing a statistical test, the success-failure condition will be that NP0 and NQ0 need to be greater than 10. P0 is 0.02, Q0 is 0.98. Now, you can check NP0 by finding out what we would see according to the null. If 2% of 800 is bad, we would see 16 bad cans according to the null. 16 is greater than 10. Make sure to work the math here. You can also do it for Q0. In this instance, 0.98 is very large. So if we would see 16 bad cans according to the null, we would see 784 good cans according to the null. Next, we need to write the null and the alternative. The null states that the true proportion of bad cans is equal to 0.02, 2%. The alternative states that the true proportion of bad cans is greater than 0.02. Make sure to be able to write your null and alternative in statistical notation, but also make sure you can read it. Reading it as a sentence is very important to being able to write these out and to know you've done it correctly. A lot of people forget to put in p, or they mix up p and mu. Mu is the true mean. We're asking whether or not a can is defective, which is a categorical question, so we need p here. If we were asking things like the weight of the can, then that would be mu, because that's a quantitative amount. So once again, p is the true proportion, mu is the true mean, and since we're looking at whether or not cans are defective, we want to understand the true proportion of defective cans. Next, we need to find our z-statistic. The z-statistic is found by taking the difference between the sample proportion, p hat, minus the true proportion according to the null, which is p0. This gives us the difference. If you'll notice up top, the difference between the two is simply 0.01. Next, we need to find p0 times q0 over n quantity square root, and divide by this. This will standardize the difference and give us a z-score. The z-score for this problem is 2.02. Now you'll notice with a z-score of 2.02, according to the empirical rule, we would have 95% between -2 and +2, and 5% on the outside. So our p-value is going to be a little bit less than 0.025. To find it out exactly, we would have to use an applet or some other tool, like the TI calculator, to get our exact p-value. Finally, we need to state our conclusion in context of the problem. If we assume an alpha level here of 0.05, we can reject the null. When we reject the null, we have evidence for the alternative. Now it's important to note that these two always stay together. I reject the null, I have evidence for the alternative. I fail to reject the null, I do not have evidence for the alternative. Also important, state your conclusion in context of the problem. For us, I reject the null that the true proportion of defective cans is equal to 0.02. I have evidence that the true proportion of defective cans is greater than 0.02. Always make sure to state your conclusion in context of the problem and that anyone could understand it. Saying you have evidence that the true proportion of defective cans is greater than 0.02 means there's some sort of problem here and that we're not happy with the rate of defective cans that we are seeing. Finally, let's solve this problem on the TI calculator. Go ahead and turn your calculator on and go over to Stat. Now, you'll want to use one prop z-test. One prop z-test will allow us to use one sample, test a proportion on the z-curve. So let's go ahead and enter in our summary statistics. We have here that we hypothesized that 2% would be bad. Now, we saw in our sample 3% bad. There's a few ways to enter that in. If in our problem it had told us 3% were bad, we would have to enter it in the following way. You'll notice that was 24. In our problem, it actually stated 24 were bad. I did this by solving p hat times n. P hat was the sample proportion of 0.03 that we saw earlier. If this confuses you, go back and check how x is calculated. X is calculated by doing p hat times n, because p hat is x over n. Next, let's go ahead and enter in n, which is 800. We need to now pick the correct alternative. The correct alternative is that the true proportion is greater than the hypothesized proportion. You'll notice the true proportion is greater than the hypothesized proportion of 0.02. P greater than 0.0, or in the context of our problem, P greater than 0.02. Putting an equal sign right here, P equals 0.02 would give us the null. Finally, let's go ahead and draw the results, and you can use calculator if your calculator won't draw due to an error. Drawing the results shows us our curve, and we can see that we landed at a z of 2.0203, and this has a p-value of 0.0217. Once again, we would reject the null here at an alpha of 0.05 and say we have evidence for alternative that the true proportion of defective cans in our population is greater than 2%.